learning begin. All right, so we're going to check in. And this time what I wanted to show you, I got a chance to get into my classroom and take out some more of my things for my students. And how we use our signals is we use a picture stick. So this is me with my school picture. And there are little spaces designed in the signal where my students can come in and, using their picture stick, can identify which zone they're in. And then if you move from zone to zone, you can move your picture stick as well. So we just use craft sticks. You can use popsicle sticks. Put a little picture of you on it, on some cardstock, so it's firm. And then do a temperature check, figure out which zone you're in, and then label your zone. It's making your zone known. We use block talk, which are the little square blocks, and then we also use our zone signal. And so today I'm in the green zone, regulated and ready to learn. So you check into your zone as well. And if you wanted to make one at home, you could also use like little Velcro dots. You can get them at dollar stores. They're super inexpensive. Just put a little picture next to it. But this is just a fun way of doing it because then it's you in the zone. Now last week, one of my students made a Mindshift project, and it's one that we normally do in our class, but because we're on house arrest, we're not going to get to do it together. So I'm putting materials together for my students, but you easily could do it as well. In our classroom, we call it a shake and settle jar. So our Mindshift this time is going to use the shake and settle jar. So what you do, and we just use we use bottles. You can use a water bottle. My son likes to have Nestle Quick, and these bottles are perfect because the labels just slip off, so it's very little prep. You just wash them out. And then you're going to put in some glitter. You can also put in some confetti. Make sure it's metallic confetti. The plastic confetti works too, but metallic confetti works better. Put 1 drop of food coloring. You fill the bottle up to the neck, so there's a little bit of room for the water to move. And then you tighten it very tight. You can glue it shut, but you can also just use painter's tape. The only reason for putting painter's tape on it is so that nobody opens it up to drink it or pour it out. And you'd want to keep it out of the reach of little tiny people because it wouldn't be safe to drink it. And then all you're going to do is you think about when you're feeling dysregulated. When you're feeling dysregulated, what happens is emotionally everything is unsettled. It's all mixed up. So when you put glitter and confetti into the shake and settle jar, you can shake it up like how you would feel when you're feeling dysregulated. And then you just watch it. And breathe. And as all the sediment settles, you settle as well. And if you need, you can shake it again or you can just turn it back over. And watch it fall. So that is a really, really, really good project to do for mindfulness. You want to not put too much food coloring in because if you do, it makes it harder to see the glitter. Bottle's pretty, but harder to see the glitter. And you can hold it or you can set it down, but what's most important is that you take deep breaths. So this was Ruben's project, and he called it the Mindful Glitter Jar. So in our class, we say shake and settle jar. But you can make one of those at home, and you can use it just to get yourself settled, regulated, and ready to learn. All right, so we're going to change up our calendar again today. And one of the things we do in our room is work on high-frequency words and sight words. So it's fishing for fluency. And just I went to what's called Fry's first 100. And if you can read those, then you go to the second 100 and the third 100. And the idea is that you just read them fast as a snap, fast as a clap, fast as a blink. That's how fast that I can think. You want to be able to retrieve those words really rapidly because even some of the high frequency words are not just words alone, they're also parts of words. They might serve as a prefix coming coming at the beginning of a word, or a suffix coming at the end of a word. And so once you know these, you can use what you know take these chunks and push it into new things that you're learning. So we are right now focusing on the green and red letter words, or the red band, red strand. What I do in my room, because I have TK, is we do 3 at a time. So we start 3 the first month, 3 the second month, and eventually what we do is we move into 1 a week, which would mean 3 over 3 week period. And we do lots and lots and lots and lots and lots of activities with them. So this is the cluster 1, this is cluster 2, and they're part of the red strand. And what you can do is you can make flashcards at home, just like this. You write the words, I do the words, vowels in red and consonants in black, just so that it's visual discrimination. And then I frame it with the color strand that I'm working on. And in my class, we do 2 clusters per strand. Kinder might do 10, first grade might do 20. And what you want to do is first be able to read them, recognize them, read them, then write them. Because the idea is to put it to the highest level of production, not just being able to see it and say it, but be able to find it in text and read it, be able to write it on demand when you want to, correctly the way that you find it in a book. So here's I, can, see, we, the, like, it, my, to, is, and we're back at I. So if you mix them up and then put them in and out of order, you can make a concentration game where you turn them over and you have to match them. You could make simple sentences and you have to put them in order. You can put a little bit of salt on a colored plate or a tray and write them in salt. You could take stones and make them, put the stones in order to either cover the word right here, or you could do it on, again, on a plate or on a countertop or a pan. You can take chalk and write them out on your sidewalk. You could take water and use a paintbrush and write it with a paintbrush and water on your sidewalk. You could use a spray bottle and spray the word. The idea is just to use it in lots and lots and lots of different contexts until you commit it to your smart brain and to memory. The other thing is keep it on display and handy and visit it often. So remember we said, well, first I made a mistake and I said that the was a high frequency word and high frequency words couldn't be spelled by sound. I had that incorrect. I flipped it over in my last lesson, but sight words are the words that you just have to know by sight because they break the rules in the coded language of English. High frequency words just mean we see them tremendously. Now the word tremendous is not a high frequency word because you only use it in a specific context. But the word the is a high frequency word because you see it in almost every sentence. It is everywhere. And it's a sight word because it cannot be spelled out by sound. In my room, we say for a word and a for a letter. There's not a right or wrong. There's just a what we do so that we can differentiate, tell the difference between the two. It, we, like, my, see, I, to, can, and is. So you want to have that on display somewhere and visit it, and then eventually you're going to retire those words off of the structures that you're keeping around you and you're going to replace them with new words, but you want to keep revisiting and using them again and again and again. Okay, so today is not the 24th. Today is the one more than 24. It's the 25th. 5 in the ones place. Yesterday was, checking my smart cards, Friday. And my face space will be lace the face space. Capital F-R-I-D-A-Y. Just a telling sentence, so we're going to end it with a period. Which means if yesterday was Friday, now we're on a weekend. Do you remember which day comes after Friday? There's 2 days. They are the bookends of the week. One is the last day and one is the first day. Saturday. So using our smart cards and our smart brain, we can transfer the information off of this card onto this board. It's just like a magic trick. Today is SAT, capital SAT, URDAY, period at the end. So if yesterday was Friday, today is Saturday, then tomorrow is the first day of the week. So we start all the way at the bottom because that's today, and we go back up to the top because remember, the days of the week are in a cycle. Repeat, 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 back again. Repeat, 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 and back again. Cycle goes over and over and over in the same order. We don't break it, or it wouldn't be a cycle. So back to the top, and it's Sunday. Capital SUNDAY, period. Yesterday was Friday, it's in the past. Today is Saturday, it's in the present. Tomorrow will be Sunday, that's in the future. So today is not Friday, April 24th. Today is Saturday, April 25th. I put a 2 in the tens place. I put a 5 in the ones place. 25, and it's still 2020. All right, so for our fun little activity, we are looking at math. Now the math magic is we're going to figure out what number represents the total amount of dots or spots that we see on each rectangle. Now if you were playing a game, you might see this in your game box, and it would be called a, drumroll please, dice. So this is how a dice is set up. Every number from 1 to 6 has a different face on the dice, and the order of how those numbers are represented is consistent. So every time you roll it, if you get this right here, you have 1, 2, 3, 4 little spots on it. If you roll it again, the 4 are not going to be placed in a different order. So this is one of the tools we can use in math to help us first recognize numbers, value, amount to 6. And second, it also helps us put sets together and take sets apart. So we use it in addition and subtraction, which we also call composition, putting together, decomposition, taking apart. So if I wanted to record the value of each face of my dice, I would need to use what math strategy? Oh yeah, counting. Good thing you told me. I just completely forgot. Good thing you're here. So I need to count them. And once I count them, the last number I state is the total number in all. All right? And we're not going to count all of them together. We're going to count each of them separately, and then we're going to record it on the line below. So since I already did this one with you, I can record what? 4. Yeah. Down and over, right? And down some more. That makes 4. Now the other thing that you can do when you're looking at dice is you can do what's called subitize. Subitize is you see a total number, and there's a total of 4, but your eye sees it in parts. So the way it's laid out here on this dice, there are 4, and I counted 4, but when I look at 4, I see 4 as there are 2 on the top, 2 on the bottom. So 2 and 2 more is 4, or 4 take away 2 equals 2. So the other thing I want you to start thinking about is seeing what's obviously there and then seeing what's hidden in plain sight. That's a really important strategy as a mathematician. Counting is the most accurate, but subitize is more efficient. So if I can count in my head and hold the number pieces, the segments away from each other, but still put them together just doing mental math, I will now have mastered an important strategy to help me be more efficient in math. And math is really about effectiveness and efficiency and accuracy. You have to be accurate. You have to be accurate in math. If there is a total number, there's a total number. Now sometimes we guess, But this isn't about guessing. This is about counting and knowing how many in all. Let's come over here, because when I look over here, this does not look the same. I think there are more. So when I look, my eye sees 2 here and 1 more, kind of looks like eyes and a nose. And then down below I see 2 more. So I see 3 and I see 2 more when I subitize. And when I count them, I see 1, 2, 3, 4, 5. Across left and down, loop right around. That is how we jive when we make up 5. Now look at the next one. I kind of see 2 here and 1 there. Or I could say I see 3 in all. 1, 2, 3. Go right around the tree, right around the tree. That makes 3. Here it kind of looks like 1 to the left, 1 to the right. 1 and 1 more is 2. 1, 2. Loop around to the right, at a left angle, come down, a line right across the bottom will do. That makes 2. This dice has a lot of dots on it. Whew. But when I look quickly and closely, it looks like there are 3 going this way and 3 going that way. 3 on the left and 3 on the right going up and down. Now let's count and check and make sure I'm correct. 1, 2, 3, 4, 5, 6. So I see 6 as 3 and 3 more. Add a left angle, come down, loop right around. That is how we get our kicks when we make a 6. All right, this one's very simple for me because I just see 1 dot, so I'm not really subitizing. I just look and I see it. I didn't even need to count it because I just knew there was only 1 thing there, so it had to be represented by this digit. A straight line down is fine. That's 1. Now make sure you are transferring this information into your composition book. Every time we do this, we're adding some more information to your schema. We're trying to dump some information in, trigger prior learning, add some new learning, and connect it to all the learning that we're doing in all the areas that we study in transitional kindergarten and 1st grade and 2nd grade and preschool. All right, so here you go. We're going to move our portable calendar. Make sure you recorded all that information, otherwise pause, complete, read it, and then resume. Now if you look at my board, we are getting ready to take a field trip. It's Saturday, good day for a field trip. Yeah, family field trip. That's all you take now. Climb aboard the bus. We're going to honk honk, beep beep, build up our schema on our learning field trip. Get on with the bunny. Robinson's rabbits are ready to roll. Now, if you look up at the top, what you see is that word that I used, that really big mouth word that I used when I was talking about seeing parts to whole. That's called subitize. Everyone say subitize. Subitize. It's a real word. It's a math word. It means seeing a number, but telling how you see it. Seeing parts within the whole. Now, I've used a couple of different structures today to help us record parts within a whole and the whole. These are called, do you remember? Do you remember? They look like little aliens. One looks like a little head with antenna and wiggly eyes at the top of the antenna. The other one looks like a body with some legs, little circly legs coming down. These are called number bonds. They bond together. We borrow that kind of from science because we look at cells and how they bond together. So these are bonding, putting 2 numbers together to make a bigger number, taking part of a number away and seeing what's left. And then this is called a what? How many boxes do you count? That's your mnemonic. 1, 2, 3, 4, 5. And then on the bottom, 6, 7, 8, 9, 10. There are 10 total. It's a tens frame. So these are the 2 ways we're going to record. Now, I hate to bug you. I just hate to bug you, but I would like you to help me with some math. So, hocus pocus, don't lose your focus. Abracadabra, alakazam. Let's turn our thinking brain into a math magician brain as fast as we can. Poof! Let's math it up. All right. Hate to bug you, but could you help me figure out How many spots are in each of these ladies? I need some help. I could look closely and maybe I'd be correct. I think maybe there are 8 here. But am I sure? For sure? How can I know for sure? I can count them. So count with me. 1, 2, 3, count with me. I'm looking at the left or the top side of the bug and I see some spots. I see 1, 2, 3, 4. So I'm going to record that here. Down to the right, down some more. That makes 4. Now I thought there were 8. In order for there to be 8, there'd have to be 4 on the other side. But when I look at the other side, it looks like there's more than 4. So let's count to make sure. 1, 2, 3, 4, 5. 5. Okay, so it can't be 8. I can start at 4, put 4 in my brain and count on, or I can start at 5 and count on. I can start with the bigger number because it's addition, so it doesn't matter which number I start with. In subtraction, it does. So I am going to start with 5, put 5 in my smart brain, 4 in my hand, and I'm going to count on. 5, 6, 7, 8, 9. So on this bug, I see 9 spots. The way that I see them is this: 4 spots and 5 more. There are 9 total, and 9 can be broken into 4 spots and 5 more. So this is taking 9 apart, and this is putting 9 together. The other thing I can do is I can show it recorded on my tens frame. So I could say 1, 2, 3, 4, and 5 more. 1, 2, 3, 4, 5. And that equals 9. And a part of how I can see 9 is there are 10 squares total, but one of those boxes doesn't have a spot, which 10 take away 1 is 9. 4 plus 5 is 9. 5 and 4 is 9. 10 take away 1 is 9. So those are all ways to record. So I could record it like this. I'm going to use my black. 4 and I use the plus sign, 5 more equals 9. Or I could say 10 take away, I could either say take away 1 or take away 9. Take away 1 equals 9. Now let's look at the next bug. Here I see 1, 2, 3. Right around the tree, right around the tree. That makes 3. On this side I see 1-to-1 correspondence. Everybody has a buddy. No one has to cry or pout because no one gets left out. So if I start at 3 and count on, 3, 3 in my hand, 4, 5, 6. 3 and 3 more is the same as 6. And 6 take away 3 equals 3. I can record it by putting 1, 2, 3 blue dots in my tens frame and putting 1, 2, 3 green dots in my tens frame. I could show this as 3 plus 3 equals 6 altogether, and 10 take away 4 blank spots equals 6. So I'm showing you different ways to record what we see. Let's try the next one. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4. 6 and 4 more. Now I could count them all on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a double-digit number, 2-digit number. And I can record it on my tens frame by putting 1, 2, 3, 4, 5, 6, and 4 more. 1, 2, 3, 4, and now I have 6 plus 4 equals 10. I could show it up here too. So I have 10 here, I could take 6 away. 10 minus 6 equals 4. Or I could say, 10 minus 4 equals 6. 10 minus 3, 4, 3. Wait, what did I do wrong here? 3, 6. Oh my gosh, 10 minus 4 equals 6. I was right. I looked at this one, then I looked at there. Look how I'm making mistakes. I see the 4 there. But on this one, what I was doing is showing 10 minus 6 equals 4. And on my 10s, or I could show 10 minus 4 equals 6. Or, I see what I did. Math, magic. If I'm using my tens frame, 10 minus 0 equals 10. What do we know about me? If I'm awake, making a mistake. So they have to be expected, now they have to be inspected. And then they have to be respected. Here's why we need to respect it, especially with math. What I just did is what's called common error. When you're doing multiple things all at one time, and math often requires showing more than one way, sometimes our brains get confused and can't hold that multiple information because it's symbolic. So it's hard to hold that extra information. So when I was working here and then I looked at there, I went, wait, if I'm showing my number bond, that's not right. But wait, 10 minus 4 is 6. Oh, in my tens frame, because I'm showing it multiple ways. So that's why it's super important to work a step and then work the next step. And showing it multiple ways, we're doing that in math now so that we can figure out, as teachers, we can help you figure out where your thinking breaks down, and we can help you figure out how to correct those errors so that you can make compressions. So on the last one, we have a ladybug that's very weighted. Now you wouldn't actually in nature find a bug like this because they're symmetrical. On the left-hand side, we see one spot. On the right-hand side, we see 1, 2, 3, 4, 5, 6, 7. 7 and one more. 7 and one more equals 8. We could also take 8 apart. So 8 take away 1 equals 7. We could show that this way. 1 plus 7 equals 8. So the equation goes down. We can flip that over. 7 plus 1 equals 8. In addition, both of the digits can trade places because it doesn't matter which goes first and which goes second. They're going to come to the same answer. But in subtraction, that isn't true. We have to have the bigger number when we're doing whole numbers. Later, when you're older, you will do fractions and you will do negative numbers, but we're not doing that yet. 8 take away 1 equals 7. 8 take away 7 equals 1. This is called the inverse operation. We switch it over just to check. So we could also do 7 plus 1 equals 8. 1 plus 7 equals 8. So we do the addition going down. We can do the subtraction going back up. 1 plus 7 equals 8. So 8 minus 7 has to equal 1. 7 plus 1 equals 8. 8 minus 1 has to equal 7. And we flipped it over here. 8 minus 1 equals 7. So 7 plus 1 has to equal 8. We do inverse operations. We're turning them over to check. That's part of how you can check addition and subtraction, is if you have to subtract, you pull them apart, you have to add the answer and the number that came at the bottom of the equation or to the right of the equation to make sure that they equal the first number. And or if you subtracted, you'd have to add the last two digits back together or numbers back together to make sure that they equal the first number. Math is super fun, but it can be so confusing. So what I want to encourage you is to prevail. One of the things we do in our room is we think about growth mindset. In order to have a growth mindful nature, you have to use mindfulness, using breath to regulate yourself, but you also have to have a growth mindset. A fixed mindset in our room, we say, is a gross mindset because you don't want to learn. You don't want to change. It's so hard, I can't do it. I don't even want to try. So in our room, what we do is we focus on some growth mindset ideas. And one of them is skills are learned, not inherited. So if you have a mom or a dad or brother or sister who are really good at math and it just comes so easily and naturally for them, you may or may not have gotten that same mental capacity, but if you work, you can learn it. So this was an awesome lesson. Thank you for sharing it with me. I can't wait to share something new with you tomorrow. But until later, little gator, here's some pride, put it inside, and have some love. You might need it now. Math is just, whew, I could feel those compressions happening in my brain. I think I need water and a nap now. Oh, I'm going to go take a nap so I can make some memories. Neurologically, that would be really helpful. All right, until later. Hang on to that schema. Don't let it slip out. Super teacher.